I'm really happy to see that so many of you showed up. It's too bad that I couldn't be there in person. Hopefully, I'll be able to meet you all next year. NDC is definitely one of my favorite conferences, and I love going to Oslo. Today, we're going to be talking about what's new in C#. We're going to be exploring some exciting new features in C# 8, 9, and 10. You'll see that C# is slowly becoming F#. All joking aside, C# is a language that takes inspiration from a lot of programming languages, F# being one of those. But also, when the language designers build features in C#, they look at Java, Swift, Kotlin, and so forth. So if you've been working in those languages, you might feel yourself familiar. So before we get into that, my name is Filip Ekberg. You might have seen me at NDC before. I've been talking about C# for the past years. And if you have any questions, please use Slido, or you can ping me on Twitter afterwards, and I'll try to answer all your questions. You can also find my courses on C# and some other topics on Pluralsight. All right. So over the years, C# has had a lot of changes coming into the language. If you've been building C# applications or .NET applications for the past 5-10 years, it wouldn't really look the same if you build an application today back when you started. We've seen changes, for instance, when you build applications that leverage asynchronous principles. Pretty early on, C# added async and await. It's been available for a few years now, but it drastically changed the way that we approach building multi-threaded and asynchronous applications. We've also had other language features that kind of changed the way that we look at building and architect our applications. One of those features is generics. It's one of those things that change the way that we look at using our types and how to construct our applications. All right, so I'll just change my screens here. And another pretty cool thing that they've added recently is something called pattern matching. I'll, of course, go through this language feature and show you exactly what that looks like. But one of the things you see with C# and other programming languages as well, when they evolve, they look at each other. C# took inspiration from F# when they introduced generics. They took inspiration from F# when they introduced pattern matching. And what I find particularly amazing with C# as a programming language is that they do everything in the open. You can go ahead and go to GitHub and have a look at what the next big thing is in the language. If you're interested in participating, implementing any language features, you can go ahead and do that if you'd so like to. But you can also, if you don't like to contribute to the compilers that are now open source, you can have a look at some of the discussions around potential language features. They're doing all of this in the open so that people can contribute with feedback that might have been working in other languages so that you can give inspiration to the design team and give some of your understanding of how you would see this added to the language. And if you don't like to participate in the discussions, you can just read up on what they want to add and how that feature would work in the language. All right, so I do encourage you to go and have a look. You can see what's coming in C# 11, 12, 13, and features that they want to add but might never add to the language. And you can see the reasoning behind those decisions. All right, so before we jump into C# 8, 9, and 10, let's go through some highlights from C# 7 to 7.3. This is where they introduced the fundamental building blocks to introduce pattern matching as a first-class citizen in the language. One of the things that they had to add to the language to make this possible was tuples. Now, tuples has been around for a very long time, but previously it was a part of the framework, and it wasn't really a part of the language itself. So how do we change this to make it a part of the language, and then make it also so that we can use this with something like pattern matching? Well, obviously, this here wouldn't work because it just uses a built-in type that uses generics. And as you see here, if I just highlight this little portion here, you can see that when we create this grouping of data, I have no idea what item 1, 2, and 3 is. And that can be a little bit confusing. So what they did with C#7 is that they introduced tuples or tuples, depending on where you're from. They introduced this as a first-class citizen in the language. Now I can create this group of fields or group of data, and I can give these fields names. It very much looks like creating a class or an anonymous type. But what I can do now is that I can use this as the return type from a method. I can use it as a parameter to a method, and I can even use this in some other ways that we are going to explore. And this tuple here is now initialized in this little variable here, and once I try to access some of these fields, we can see that we have some named parameters. This makes it a whole lot easier to work with tuples and use them and leverage that later on with pattern matching. So even though you might not end up writing your code like this here, this is one of the building blocks needed to go forward to the changes that are coming in C#8. What they also added was the capability of deconstructing an object. That means that we can take an object, pull it apart, and have a little bit of a different way of looking at a representation of that type. So what I mean about that is that if we look at this method here, it doesn't override. It's simply I would say it's a magic naming convention, or it's a convention of how you build this method. So as soon as you add a method called deconstruct that also has a few out parameters, you can take this and you can assign your type to a tuple, and it pulls that object apart and it brings it into this tuple that I have here on the left-hand side. So now I took let's say this is an instance of a person. When I pull that apart and deconstruct the object, it will return the name as well as an age. And it can be deconstructed into these two local fields. So this here is an interesting change as well, because this means that I can now add this method to my objects, and I can add multiple different ones. Let's say that I have a deconstruct method that would also give me the address or my place of birth and a whole lot of different things. I could pull this object apart into different representations, which would all return tuples. And you'll see why this is important when we look at pattern matching as well. So tuples and deconstruction, they are kind of used together. I would say that most of the time you use these together. And another way of looking at this is, in this case here, I have this local variable that I call coordinates. This local variable has an x and a y field. This syntax here defines that the coordinates variable is a tuple. And then I assign the first value to 10 and the second one to 20. And then I can access those fields, of course, like you could with any object. Another way of looking at this is if we have a class called coordinates, and I want to be able to simply assign that to two local fields. To do this, it would be required that I add this deconstruct method, and everything would just work out of the box. So if you add the deconstruct method to your classes, you will be able to get a representation of that class into a tuple and deconstruct the object. So these two language features were very welcome in C#7 through 7.3. What they also introduced was the capability of building asynchronous main methods. Now, this might seem like a very small feature, but if you build a console application, like most of us do, you want to be able to use asynchronous code. This could be used, for instance, if you have a service that's running in Windows, or you have something that's scheduled to run all the time. It's really nice that you can now mark your main method as async, but also requires you to return a task, and then you can use the await keyword inside the main method. Might look like a very small thing to add, but this was also in preparation for what's coming in C#9, which is something called top-level statements. So the way that we look at building C# applications and .NET applications in general, it's going to change over the years. And if you do a file new project in the latest version of Visual Studio, that's going to look very different from what it did 5 years ago. But we'll get to that soon. So now with that out of the way, and we've looked at the tuples and deconstruction, we can discuss what's coming in C#8, or what did come in C#8. So C#8 introduced quite a lot of features. And the reason that they are capable of adding this many features into the language is mainly because they decided to rewrite the compilers. They rewrote the compilers, and the C#6 version was the first version released on that brand new compiler. A fun fact around that is that they had to reproduce all the bugs from the old compilers because Microsoft don't like to do breaking changes, and fixing a bug could potentially be a breaking change. So with C#6, 7, and 8, we got a whole bunch of features. And specifically with C#8, we're going to look at a few of these that, again, change the way that we look at building our applications. The whole idea behind introducing new language features is mainly due to the fact that we want to be able to express an intent that we might have been able to do before, but do that in a slightly different manner. We want to be able to express ourselves in a way that makes it more understandable, hopefully introduces less bugs, but also is really maintainable and a solid implementation. So we want to trust the compiler to do a good job for us. Now, with C#8, one of the things, or I'll list a few of the language features. We're not going to be able to cover all of them, but I'll go ahead and go into Visual Studio and cover a few of them. They introduced read-only members, something called default interface implementations, and don't worry, we're going to look at a few of these soon. They also did a few changes to pattern matching. In fact, they changed the way that pattern matching works in whole, and how you look at using pattern matching, which is why I didn't show you how that worked in C#7, because it drastically changed in how you use that in C#8. They introduced helpers to use something called a switch expression. They introduced a lot of patterns that let you determine what an object is and what kind of attributes you have on that object. They introduced something called using declarations, static local functions, nullable reference types, which changed the way that we look at nullability and how to avoid null reference exceptions. If you've done any asynchronous programming, you might have been thinking about streaming data, and how do you stream data from one point to another and consume that stream asynchronously. You haven't been able to do that in a really nice manner before, but now in C#8, they introduced something called asynchronous streams. And together with that, we also got something called asynchronous disposables. We got some helpers to work with ranges and indices, or indexes, that lets you slice off data. And the ones that I've highlighted here are those of the features that I'm going to dig a little bit deeper into. We also got something called null equalizing assignments. So I guess the question now is that I want to jump on and use these features. And I'm going to go into Visual Studio and VS Code and use all of this. But I've already prepared my machine here with all that I need to run this. But if you want to do this on your local machine at work or at home, you'll need to know that in order for you to use C#8 or C#9, for that matter, you might need to install a new version of Visual Studio. You might need to run a very specific version of .NET. So for C#8 and 9, you need VS 2019. And for .NET 8, or for C#8, you need .NET Core 3.0. For C#9, you need .NET 5. For C#6, you need .NET 6. It can be a little bit confusing, because these languages, or these language versions, they don't just introduce compiler magic or things inside the compiler that works for older runtimes. Some of the features they introduce is also something that requires a new runtime. And knowing which runtime you need can be a little bit tricky. But fortunately enough, Visual Studio will let us know if we're trying to target a feature that doesn't exist. Sometimes you can even go back and compile. For instance, you can use some C#10 features and run them on old .NET framework, as long as that language feature is just compiler magic. but unless you know that it is, it might or might not work. So a good rule of thumb is use the latest version, at least the latest version of .NET, that's the long-time support, which is now .NET 6, and that lets you use C#10. But this also means that we might need to look at, if you're working in Windows applications, for instance, and you haven't been in the .NET space for a while, one of the worries was that I can't just jump on .NET Core or .NET 5 or .NET 6 because I'm working in WPF or I'm working in WinForms. But of course, fortunately enough for us, Microsoft has made a change so that you can now do WPF applications on .NET Framework, on .NET Core, and now also .NET. And if you want to know what the difference is between .NET Core, .NET Framework, and .NET, that's a whole other talk. Basically, .NET is the one thing going forward, so .NET 6 is what you should be using if you're creating new applications. Okay, and you can do the same thing for WinForms as well. Now, one of the C#8 language features that I talked about, or just briefly mentioned, is something called default interface implementations. Now, this language feature requires a runtime change because it changed the way that interfaces works internally. This here looks very much like a class. If you look at this little portion here, this here is a method body. I'm using an expression-bodied member. But I have this interface called iProductRepository. It's not a class. So how come I can have this implementation inside my interface? The reason is that in C#8, they introduced something called default interface implementations, which lets you provide a default way that your methods work on an interface. So it's sort of like a class without the instance of a class. Hopefully that makes sense. So why would you use this, you might ask? It's great for library developers. If you have a NuGet package that you manage or that you provide support for, and you want to update that with a breaking change, you can introduce new methods on your interfaces, provide a default implementation without breaking people that are using your interface. And then you can deprecate that, for instance, in a later version. So it's a welcoming feature for those of us that work with open source projects, or for those that work with open source projects. And then if you try to use this with a target runtime that doesn't support it, so let's say that you try to build this for .NET Framework, you'll get this little warning that tells you that the runtime does not support default interface implementations. So it's good that the compiler tells us that there's a potential problem and that we need to go ahead and do something else for that particular runtime or that particular implementation. All right, so let's now go ahead and look at some of the more interesting and useful features of C#8. I do reckon that most of you, if you've worked in .NET or if you've worked in development at all, you've probably encountered a null reference exception. So there's a very welcoming change, or a very welcome change in C#8 that introduces something called a nullable reference type. Now, null reference exceptions can occur in many different types of applications. And the biggest issue here is that we have an object that's not set to an instance, right? And sometimes when we return null from a method, that might be the intent of whoever wrote that method. But if we always need to guard against nulls, our code is going to become very, very hard to maintain. So if we were to look at this problem, let's say 20 years ago, and know that in 2021, this would have costed the world millions and billions of dollars, right? The null reference exceptions has costed the world so much money that it's really hard to keep track. And if they were to redesign C# as a programming language, I do reckon that they would make it harder for us to use null references in the language. If you've done other programming languages, like Kotlin, for instance, they make it really hard to use nulls in the language. You have to always explicitly say that you want to use something that's null or set something to null. So what's really the problem with nullability? One of the problems is that we need to introduce null checks all over the place, which essentially makes the code a lot harder to maintain and read. And there's also the problem that what does nulls really mean in the language or in our applications? Does it mean that the objects were not found? Does it mean that we had an error? It also encourages mutability. And that becomes a big problem when we get into multi-threaded applications. Right, so C# 8 somehow solves this problem by introducing something called nullable reference types, because we want to avoid having to write code that looks like this here, right? Becomes really messy. If we have to write this portion of the code here or this each time that we don't have to, that becomes harder to maintain, which is why they introduced this feature to enable something in the language that completely changes how it looks at something that could potentially be null. If I add this little portion of code here to my application, and I use something that's null, it's going to tell me that you're accessing something here that could potentially throw a null reference exception, right? So name could be null. So how about we just go into Visual Studio, and I'll show you a little bit of a program. Okay. This application is inside Visual Studio 2022. You could use 2019 as well because it's C# 8. What you'll see here is that I have a normal solution with a normal project. If I go into my CS_proj file, I could also do this from the property window, but I'll show you this in the CS_proj file here using text. I can enable something called Nullable here. If I do this, it's now going to change how this looks at reference types. If I save this here, the compiler will now look at my reference types as not allowing to be set to null. It won't prevent me from setting anything to null if I want to. For instance, I can still set, if I create a person, I could still set that to null if I wanted to. But if I do that, I'll show you what happens. I'll do, let's see here, or P1. Let's do person. P1 is equal to null. It will now tell me that you shouldn't do this. We're going to get a warning here saying that you should not use null here because this here is a reference type, and we've told the compiler that we no longer want to use nulls in our application. So every time that we want to explicitly use something that could be null, we have to use a question mark. And now you might have seen here the little squiggly here beneath null disappeared. Because now I say that this person here, P1, is allowed to be null. This is a very simple and an easy example, but let's look at our class here and see if we can find any potential problems. If I scroll down, I have two classes. One details class that has two public properties. It's telling me here that there's a potential problem here because they're not initialized. This here is a new language feature introduced in C# 9 called Init only properties. It allows me to make sure that I can initialize these with a value only once. Now, in order for me to fix this problem, I could introduce a constructor, right? I could say that I have a, you see the squiggly here now is now under details because it expects me to have a first name passed in here, last name, and I can set first name to first name and last name to last name. So what's the problem with going around and doing this for all our classes? We've now changed the contract for the entire application. Everyone that's using this details class now needs to go ahead and initialize this. So an alternative approach in this scenario would be to allow them to be null so that I can get rid of this error here, which is fine because I don't care if first name or last name are not initialized. And the same goes for my person class. It has a reference here to my details instance. I can say that this can be null as well. All right, so that's all good. This wasn't really going to cause any null reference exceptions anyways. So let's continue exploring the application and see what it says here. If I expand this this method here called attendance, which returns an INumerable of person. Look at that. This here returns null. So this here tells me that you could have a potential null reference exception. And if I start saying that I can return null from here, the warning would move somewhere else. So whoever calls attendance here, let me just show you what happens. If I say that this can return null, the problem or the warning goes up here to the top. And we can go ahead and handle this accordingly. So all of a sudden, we change the way that we look at reference types. We let the compiler tell us when there's a potential problem. But instead, of course, we want to fix this. And a way to do that is to simply just return an instance of a person instead. Is to return an instance of that person. And we can easily do that. You don't have to see me write all this code. I'll just copy that in here, and I'll just go through what's happening. I create a new version of a person, a new instance, and then I just yield return that. Yield return is a way for us to create this, this enumerable. Instead of having to do a new list and add the person to the list and then return that, I can just use yield return to indicate to this INumerable that there's a new instance of this person. And while we're inside this little snippet here, did you know that you can also just remove the details here? You don't have to explicitly say the class anymore. Can now do new like this. This here is called target type new expressions. So you don't have to explicitly say, well, I can do it there because it doesn't know it's a person. All right, so now this here, the problem here is fixed. Let's expand the application a little bit more and see if there's any problems. Look at that. We have one more warning where we try to access the details. So this method here takes this INumerable of person, takes a list of people, just for reaches over all of them. It tries to access one of the properties, and it tells us when you do this, if it's not initialized, you're going to have a problem. So this is one of the places where it's appropriate to check if person.details is equal to null. Well, if it's not null, right? Could do that. We could also use another approach here, which uses pattern matching to say if this is an initialized object. I don't know which one you prefer. You could also say it's not null. That would also work. There's multiple ways. You can choose whichever way you like. But as you see here, the compiler understands that details will never be null here. So let me show you another approach here. How about we know that this might be null and we can provide a default value? Or in some cases, we might know that this here is going to be instantiated. We know better than the compiler. This here is called the dammit operator, or null forgiving operator. It's officially called the null forgiving operator, but damn it, I'm better than the compiler, right? So how often do you think this here is going to be appropriate? It would be appropriate if you, for instance, get something like first or default, and you check that on the line above, and then you do it again at the second line. But the compiler is not really smart enough here. Let me show you an example. I can do person p1 is equal to null. And this is going to give me a warning, but I can promise that null isn't null. And I've now tricked the compiler, but we can obviously see here that this is not true, right? We know that this is null here. This forgiving operator is just a way for us to tell the compiler, I don't care. So be very careful when you use this. Instead, try to handle your null references like this here. And if you enable the nullable reference types, you can either do that in the CS_prod file by doing nullable enabled. You can go ahead and do it for the entire class or the entire file by saying nullable enable. If you have a method that you don't really want to care about right now, you could say that I want to disable this for this particular method. And that would disable it for the main method. So you can use this compiler directive to instruct the compiler how to look at the nullable references. All right. So let's see here. These nullable reference types are really amazing. And one of the things that you can do as well is that you could treat these warnings as errors, right? So you can instruct the compiler to look at all the warnings in the application as errors. And if you do that, I've heard about people doing this, and it's really amazing because I have a lot of errors in my applications, and I don't always tend to fix them. So if you treat warnings as errors, your build pipeline is going to fail. In this case here, if we have uninitialized values, or if we have properties or accessing properties that could be null. So this is a nice guard against nulls, and a good way to make sure that you don't have any problems when you run the application. So I do believe that this is a really great addition to the language. And one of the things that they're promoting, or they're trying to get rid of nulls completely, there are different ways of looking at treating or using nulls, right? We could be using something like maybe or either from other programming languages. F# has the maybe, Kotlin has either, and you can use that, and I believe that that's coming to C# as well sometime in the future. But for now, this is the next best thing to not having nulls at all. The next really great feature added to C#8 is asynchronous streams. Now, this language feature allows us to consume a stream of data and consume the items as they arrive to the application. Let's look at an example of how that works. I will assume that you understand a little bit about asynchronous programming. This here is a top-level statement. It's a new project the new C# project or .NET project templates. I can show you that soon as well. But the first thing you'll see here, I have a normal method here. I have the async keyword to indicate that this here is an asynchronous method, but without the await keyword, that means nothing at all. And then I use this new thing. You might have seen async used together with task before, but now I have this new thing called async enumerable. This here indicates that I will have a stream of data that's asynchronously going to retrieve strings that are going to be returned back to whoever calls this method readlines async. It's going to be returned to the caller as that data arrives. So the async enumerable indicates that the data will be streamed back to whoever consumes this method. Where the real magic happens here, again, it's this yield keyword. This here tells the iterator that there's now a new item to process. If you've ever tried to use the yield keyword before, together with the async keyword, you know that it hasn't been possible. And now we can construct this stream of data where we use the yield keyword together with this async enumerable. And then just to fill it in with some blanks here, we are opening a file, we're opening a stream to a file on disk. I'm using this also new language feature from C#8 called using declaration. You see that I have this using block here. It ends with a semicolon. What that means is that when this method ends here at the bottom, this is going to be disposed. If you add the await keyword in front of the using block, that's using the asynchronous disposable. All right, and now this is where the magic happens. Each item is retrieved asynchronously. We read a line from disk, we do that asynchronously, and when we read something or load something asynchronously, the control is returned back to whoever consumes this method, and they can do whatever they want. And to make it a little bit more interesting, I added a await task.delay here just to make it a little bit longer, because reading from my disk here, I have a really fast SSD drive. Loading a small text file is really quick. Okay, so this is nice. How do I then consume this? Well, if you'd have to guess, you probably might have guessed that you use enumerable for each loop. The difference, though, is that you have the await keyword in front of the for each loop. Okay, so you say await for each element that I retrieve from the method getElements. Let's have a look at what this looks like. Just going to have a look at Slido so we don't have any questions. Okay. So this method is fairly, it's almost identical, except I would just point this to a different file. I have async enumerable, and this is a program.cs file. It's using this new top-level statement. You no longer have to do the public static void main stuff. It's all generated behind the scenes for us. So basically, you can create a new program.cs file and just start writing code here from top to bottom. You also, this is a side note, you also see that I don't have any usings or anything like that, but I can still use system.io. I can use system.collection, I believe this lives in. And I can use a whole lot of other things. That's because .NET 6 introduced something called implicit usings. I'll go into the CS project file. If you add this to a .NET 6 project, well, this is turned on by default. Implicit usings means that it's going to try and include everything that you're using without you having to use any using statements, which is a nice feature as well. It also enables nullable reference types by default. All right, back to the asynchronous streams. This method is almost identical, as I just mentioned. I use this using stream here. It's a using declaration. I load each line separately here. I say await each line that I load here. Then I just have this fake thing to say that I do something with the data. Let's say that I have to process this. It takes 500 milliseconds. It's just to make it a little bit more interesting. In order for me to consume this now, I have to say await reach var line in get lyrics. And IntelliSense in VS Code and top-level statements is not the best so far. So let's do console.writeLine and line here. The idea here is that each line that I get out of this for each loop, we have to await that. If we had the await keyword in front of get lyrics like this, it would mean that all the data was loaded in one chunk, right? But now we want to asynchronously retrieve each item. If I save this and I go into my Windows terminal here, and I do .NET run, this here is now going to build the application, it's going to run it, and it's going to stream this data from that file. And maybe you recognize this song. All right. So that's a really handy feature. Of course, in a console application, that doesn't really make a lot of sense, but it's a good way of just isolating exactly what happens. Right? It shows you how you can read one line at a time. You could search for something. You could, for instance, then stop loading it. If you have a break here, right? If you just break here, it will only load one of the lines. So it won't continue loading all of it. It means that you have a smaller memory footprint. It also means that it's going to be a little bit faster. So if you have, for instance, an ASP.NET application, and you use these asynchronous streams in your actions, of course, the data wouldn't be streamed back to the caller of that website. It would be streamed back to your web server, and then when you have the result, you can aggregate that and work with that, and then return it back to whoever calls your website. But if you use something like Blazor, or if you have, for instance, SignalR, or if you build a Windows application, this here can be a really powerful feature to get data into the application very quickly. All right. We do have one question. Does the method return as soon, does the method return, let's see here. I believe the question is if it starts reading the next line before whoever processes this handles it. And the question is no. So it gets one line, and you can process that. So it loads the line from get lyrics. That takes 500 milliseconds because we have await here. And what happens internally is the same as a normal iterator. So it's going to call get next item or load next item or whatever that's called in the implementation. I believe it's next or get next. If you do break here, it won't go ahead and load anything other than the line you just processed. And when you break here, there's a lot of things happening internally here. When you do break here, when this for each loop ends, remember this here uses this using statement. That means that it has to go back and clean that up. So when it breaks out of this, it's going to then go back to this state machine generated for this method. It's very complex what happens internally, which is really good because we don't want to care about that. We simply want to consume this as a stream of data. Okay? Hopefully that answers the question. Otherwise, I can elaborate more after this talk. Now, there's one more really great feature added to C#. And they started off with adding this in C#7. But at that point, the introduction of pattern matching was just a very basic implementation. You could match on an object. You could use it with a normal switch. The whole idea with pattern matching is that you look at traits of an object. You identify, for instance, in this case, I have this pile of fruit here. Some fruit is edible, some fruit needs to be peeled, some fruits are green, yellow, and so forth. All of those things are attributes of those objects. And of course, we've been able to match on attributes and properties and all of that in prior versions as well. In fact, you've been able to do this in C#1 through C#6. But it wasn't really as intuitive as you would have wanted. For instance, matching on a type and an attribute in C#1 to 6, you would first have to get the type, compare that to the type you're looking for, and then you try to access one of the properties. If this property only lives on the type you're looking for, you'd first have to cast it. And the code becomes quite nasty, to be honest. And in C#7, they sort of improved on this. They added the capability of using the switch, the normal switch block, and then use a first version of pattern matching, where you use a type pattern to say, in the case of this being an apple, so this line here is sort of identical to these two up here at the top. What's interesting is that it matches on the type, it captures that type as the correct instance or as the correct type. So inside this case here, you can use it as the concrete type that you're matching on. But of course, this here could have been improved upon. I don't really think there's a few more characters here than the example above, and I don't think this reads as nice as the if statement. So while it was a good introduction of matching on a type, maybe that wasn't really good enough. That's why C#8 introduces something called a switch expression. The switch expression is sort of a new way of writing this line of code here. You have an object that you want to create patterns for. And based on those different patterns, you want to do certain things. You fill this switch body with expressions, which is why it's called a switch expression. Okay, so you first have your input, which could be your fruit or your person or whatever you want to do, right? And then you fill this with your patterns. This here is a type pattern, and this here is what is returned when the pattern is a match. You can see here we have the expression here, which says that everything to the right here is going to be returned, and it's going to be stored in this variable. It could be a string, it doesn't have to be, it could be any type of object, really. This here is the type pattern. This here, the underscore, is the discard. Discard has also been around for a little while. It allows you to say that I don't care. In this case, it's a default expression. So whenever it couldn't match on anything else, maybe it's an orange, maybe it's something else, then it would match on that. So what patterns are there in C#8 and 9 that will make our lives so much easier? Well, there's quite a few of them, and we're going to try and look at as many as possible before my time runs out. We have something called a type pattern, we have a positional pattern, we have a property pattern, we have a tuple pattern, relational pattern, we have AND patterns, OR patterns, parenthesized patterns, negated not patterns, and best of all, something called recursive patterns. Don't worry, we're going to look at a few of these soon, so you don't have to remember all of them. The recursive patterns allows you to use one or more of these together with each other. For instance, let's say that I want to match on a type, as well as checking a property. I could then use the type pattern as well as the property pattern. Let's say that I want to check a type, property, and compare that to something else. So you can start building these really complex expressions, but the more complex they get, the harder your code will be to read. So you should be quite careful with having too complex patterns as well. An example here is the property pattern, for instance. I have this switch expression, I have the type pattern here, and then I want to match on a particular property. Okay, so I could say that the color needs to be green, and then this here is what's returned after that. Okay, so what about if we just jump over to Visual Studio, and I'll just show you this instead. We'll do this but in a completely new project. Let me add a new console application. I'm going to make sure that I don't click VB. And let me show you here. So let's call it C#. C#9 is going to be the new project. And here we can see that I'm on .NET 6. Doesn't matter. You can be on .NET 5 as well. There's not going to be any new patterns in .NET 6 or that require .NET 6 that we're going to use here. So I'm going to create this here, and you'll immediately see one thing. This is the top level statement. This is the completely new project structure. You have your program file. You don't have to do the public static void main stuff anymore. So let me bring over a file here. I'm going to copy this file called test results. It's a simple class that gives me the number of tests of a test result. Let's say that this is a test for a university course or whatever. If it's valid, how many times you've attempted the test, the date, and so forth. And then we have a deconstruct method, which gives you how many days since you did the test, and if it's still valid. You can see here that the deconstruct method doesn't have to return the properties. It can return whatever. It doesn't have to match the exact amount of properties on your class. This thing can return whatever, right? And then we have a subclass called negative and one called positive, like a failure test and a succeeded test. And then, let's see here, then we want to go into our program file, and we want to construct a test result. So let's do test results equal to new test result. But we want to do positive. So if I want to create a pattern for this, I want to compute the outcome of my particular test. I could say var outcome is equal to test result and switch. And then inside this switch expression here, I can say that, well, if I don't know what the outcome is, I'm going to say that it's inconclusive. Not available. I can't spell, so let's go with not available. And now I can start adding expressions in here to say that, well, what about if this is a positive test? I want to say positive. Okay. And if I want to add a more granular pattern to say that, well, it needs to be positive. It needs to be positive. Why does this not work? Positive. And the number of tests need to be less than 10. If that's the case, then I want to say, let's do a colon here, positive less than 10. So if you want to be more granular to match on a particular pattern, that pattern needs to go above the one that kind of captures all of it, like a normal switch statement, right? So if you were to add the catch-all for all positive tests at the top here, it would say that this here is already, this will never be reached, right? It's unreachable. Okay, so now we have two cool things here. First, we have the pattern for a type pattern. We have a property pattern to check the number of tests. This here is a relational pattern, which means that I can say I want this integer to be less than 10 or less or equal to 10. Or, this is the disjunctive or pattern, or I want this to be more than 20. Okay? As I mentioned before, this can become rather hard to read if you have some really complex patterns here. And of course, you can use the different patterns that you have here. So we have something called the tuple pattern as well. You can say that if you take this test result and you deconstruct that, you can use something called the positional pattern. So I could say, let's see here, I can't remember exactly what the deconstruct method did. This is one of the reasons that it can be a little bit tricky to use this pattern. So the first one is an integer, the second one is a Boolean. So I could say 10 and false. And in 2 days, I will have no idea whatever this means. Unless I do use something called days. I can use name parameters here as well. Then it becomes a little bit more readable. This here is a positional pattern. It says that the first one needs to be exactly 10. The second property needs to be false. I can also say that I don't care if the second one is true or false. So they've added all of these really great patterns, like this property pattern, the relational pattern. You can say that it needs to be and here instead, and then of course it needs to be above 10 or less and less than 20, right? So you can use the conjunctive and pattern or disjunctive or pattern. You can use the type pattern. And this here allows you to match on what's outputted from that deconstruct method. What's interesting with this, though, is that this doesn't care if it's positive, negative, or some other type of test. If you also want to say that this needs to be a positive test, you have to say that this is a positive test that we can pull apart and match to this exact tuple or these exact values. So the different patterns that you can use are going to make it easier for you to construct code that makes a little bit more sense. And you can use these patterns not only with the switch expression. You can do the exact same thing in an if block. If test result is this thing, then it's going to enter that block. Of course, the more the more advanced you make your pattern, the harder that is going to be to understand and maintain. Of course, this here is a very simple one to understand, but you can make it as long as you want, and you just have to be careful to not make your code hard to maintain. Okay. So all of these different patterns allow you to express yourself in a new manner, and I do believe it's a really good addition to the language itself and the different patterns available. And with each version of C#, I do believe we're going to see more patterns added. In C#10, they're extending the property pattern. So in this case here, if this was a reference type and you had a property that you wanted to match on that, you could just do dot and then call that property. This here is the tuple pattern. You construct a tuple here, for instance. You have 2 or 3 or 4 or 5 values. It needs to be minimum 2 to create a tuple. And then you can match on exactly that. The discard here means that you don't care about the value. Here's another example of a tuple pattern. Or sorry, this here is the tuple pattern and positional patterns. It's kind of the same thing. They're kind of indistinguishable. All right. So here you say you have a type pattern and you want to match on this deconstructed type. So these different ways of expressing yourself hopefully makes it easier for you to construct code that makes it easier for you to determine what types you're looking for. And I've used this extensively in C# and Kotlin and Swift and F#. So for C#9, we've already covered some of the language features. There's one in particular that's really interesting that I want to spend the last, I believe we have 5-6 minutes left on, and that's record types, which is one of those really great features as well that makes it easier for us to build up new reference types and get a lot of functionality out of the box. C#9 also introduced what I showed you earlier with the init-only setters and the top-level statements. There were also a few pattern matching enhancements and the target type new expression, and then a few language features that are more targeted towards more performant capable applications. Most of the ones I haven't highlighted here in black are the ones that I haven't used much at all in the real world. But some of the language features introduced in the languages are very particular for certain applications. Like static anonymous methods, for instance, it's a performance improvement. If you use a lot of anonymous methods, maybe that's one of those things that you'd be very keen on using. So I want to show you the record types. It's a very nice language feature. Let me go ahead and go into to top-level statement here, or a top-level program. This is the same application we looked at earlier, and just kind of comment out the code here. The record types is a way to represent a reference type. Instead of saying class person, for instance, and having a default constructor, public person, and so forth, right? Instead of having to write all of that code, why not just allow me to express that I want a person that requires you to have a name as well as an age? And if I do this, this here is now going to, behind the scenes, create a class. This class is going to have a lot of really great functionality built in. For instance, it's going to have a deconstruct method. It's going to have the capability of copying this record here, because records are immutable. It means that I can't change the name after it's been created. I can't change the age of this person after I've created the record. So an example of this is var Filip is equal to new person. And let's enter my age here. And now I'm capable of creating this new reference type here. And if I try to change my name all of a sudden, I'm not able to do that, because this here is an init only property. It can only be initialized with the type itself. If I want to get a completely new person out of this here, I'd have to say var Filip2, let's say Filip with name. And now this new thing here called the with expression allows me to grab this person that I created up here, make a complete copy of that with this new name set to it. And I can even set the name to the same thing. And what happens if we try to compare Filip with Filip2? They have the same name, and hopefully they have the same age. Normally when you compare reference types, it would compare the reference. But with these record types that we have here, it's slightly different. If I run this, it's going to say that they're the same. Because record types out of the box provides value-based equality. It means that it's going to compare each property with the other properties. We can even go ahead and go into SharpLab. And if I have the same code here, I have record person. Hopefully this is visible here. I have the record person, string name, int age, the same thing I had in Visual Studio Code. And this here is all the generated code that we get out of that. We have this person class. It's an I-equatable of person. It gives us the equality checks. It makes sure that it's immutable. This here generates so much code behind the scenes to make it easier for us to work with this reference type. So I do believe that these record types are going to replace the way that we work with domain objects or domain models that we might have. And if you want to add methods to it, you can just use them like a normal class. You can even add your own properties. That works as well. So a record works very much like a class because it is a class behind the scenes. This here is not immutable by default. So just keep that in mind. You can add things to a record that's not immutable, but these fields or properties added to the primary constructor, this here is known as a primary constructor, that's immutable. Those are immutable by default. All right, so we've looked at the records. We saw the init only. We've seen top-level statements and the target type new expression as well. And honestly, in C#10, they didn't introduce too many awesome features. They focused on just getting, I believe, .NET 6 out of the window, but they did add record struct. So if you have a struct, you want to create that as a record and get the same functionality sort of that you have on your record classes, you can do that as well. And they did some other interesting things as well, like global using directives. You can go ahead and say that, for instance, if you want, I'll just show you. If you want system.link to be available in your entire application, you can just add a global to the front of this here. Now this is .NET 5, so it doesn't work, but in .NET 6 it does. So this here's a global using directive. They've also added the support for doing file scoped namespace declarations, so that you can, instead of having to wrap everything inside these curly brackets here, you could just do namespace semicolon, and that's the namespace for the entire file. So that works if you're targeting .NET 6. Okay. And they did some property pattern improvements as well, improved Lambda expressions, and constant interpolated strings, and some other features as well. So I mean, if we just look at what's next, C# 11 is going to add more patterns. And I guess from the new versions of C# going forward, that's what they're going to focus on. More patterns, more features to make it easier for us to write code that makes more sense, that's easier to maintain, and requires less keystrokes, basically. They're also going to add something called name of operators. And finally, hopefully, we'll get generic attributes. That's been on the list for quite a few versions now. And also looking at some other features that they might add. All right. So if you want to learn more about my stuff, if you want to learn more about C#, I have a bunch of Pluralsight courses. Please go ahead and check that out. And if you have any questions after this talk, I'll have a look at Slido if there's anything. Other than that, we'll close for now. And I want to thank everyone for attending the session. I'm available on Twitter. Please do reach out if you have any questions or ask.